Good morning, afternoon, or evening, cats and dogs. This video is going to focus on the lesson 5.5 guided notes on simplifying algebraic expressions. A lot of the concepts that we're learning in this unit are really going to be foundational for work you're going to do later on this year and next year and even in the years to come. This is one of those lessons that's going to be really important for us. The first part of what we're going to cover in this video is identifying terms like terms, coefficients, and constants from an algebraic expression. That's not as important, but being familiar with these words is important because I'll use them in class, and some of your other math teachers will use them as well. The second part of this will focus on simplifying algebraic expressions. You'll see some pretty easy examples today, but they'll eventually get to be more challenging. So it's really important to pay attention closely to this video and make sure you're jotting down the guided notes in your own notes. All right, so let's begin with the key vocabulary related to this lesson. The first word we have is the word term. A term is each part of an algebraic expression separated by an addition sign. That's really important. It needs to be separated by an addition sign, not a subtraction sign. So each time we are presented with an algebraic expression, we are going to add the opposite and rewrite it as an addition expression before we start identifying these terms like terms, coefficients, and constants. I like to think of the terms as the ingredients that are being added together to create your algebraic expression. Like terms are specific types of terms that contain the same variable or variables. We'll be identifying some of those down below and identifying them in some algebraic expressions. These are important because you can add and subtract like terms, but if they aren't like terms, you can't add and subtract them. We briefly introduced this to you in the last lesson, but we haven't seen a lot of examples of like terms at this point. The coefficient, this is probably a new word for you, is the number part of a term that contains a variable. What's really important here is it has to be a term that contains a variable that has a coefficient. A term that does not contain a variable, which is just a number, is a constant, not a coefficient. So that's our last key vocabulary word here. Again, a constant is a term without a variable. And I can't stress this enough, to always add the opposite before you identify key parts of algebraic expressions. We'll do that in just a couple of moments. I took these last questions from the textbook just because I think they were good problems with us identifying the variables and identifying like terms. So it says to underline the variable or variables in each term, then cross out the term in each group that is not like the other two terms. So in this first row that we have, we've got 5x, x is our variable, 4y, y is our variable, and 7x, x is our variable. The one that is different is 4y because it contains a y, whereas the other two contain x's. In our next row, we've got 3c, c is the variable, negative 2c, c is the variable, and 6d, where d is the variable. The one that's different is 6d because it has a d attached instead of a c. Next, we have 2mn, both m and n are our variables, 3np, both n and p are our variables, and 6np, where both n and p are our variables. 2mn is the one that doesn't fit with the other two since it has both an m and an n attached. Again, they need to have the exact same variables. Then our last example, 5rs, negative 5rs, and 5st. The one that is different is the 5st. Even though it has the same coefficient as 5rs, it doesn't have the exact same variables, so it is not a like term. All right, at the very bottom of that page, there are 3 examples that I typed up to give you some examples of how to work through these problems. In terms of these examples, I would suggest maybe going back, looking over some of these practice problems, trying some of these on your own if you choose. If you're really struggling with identifying terms like terms, coefficients, and constants, read through these. I don't want to read through examples that are already typed up because I know you can do that. We will do some problems together, though, on the back of this page in just a moment. I want to stress a couple of things, though. First off, every algebraic expression doesn't have to have each of these elements. For example, this expression in example 3 does not contain a constant, and that's certainly possible. We'll also see an example today where you will not have any like terms, and that also can happen. So just be aware that every expression doesn't have to have well, it should have terms, but it may not have like terms. It's possible it might not have coefficients if it doesn't have any variables, but then it's not going to be an algebraic expression, but it might not have constants because those are the numbers that are by itself. For example, example 3. So let's go through some practice of identifying terms, like terms, coefficients, and constants. And again, I can't stress enough that while this may not be the most important topic, these words are going to be used throughout this year and in future years, so I want you to be familiar with them. So in the directions, it asks us to identify the terms, like terms, coefficients, and constants. Before we do that, though, please rewrite your expression using addition like I did down here. So 5a plus 2a minus 3 plus 4a can be rewritten as 5a plus 2a plus negative 3 plus 4a. Now, my terms are the things that we're adding together. That would be 5a, 2a, negative 3, and negative 4a. So you can see that I listed them here. 5a, 2a, negative 3, and 4a. Watch your signs. The number one mistake students make is they just put a positive 3 because they're like, there's a 3 right there. That's one of the reasons why we add the opposite. Like terms. We have a group of like terms here. 5a, 2a, and 4a all contain a's, so they are all like terms. Coefficients. If we look over our list of terms again, we choose those terms that contain variables and take the number that's in front of the variable. So that should be 5, 2, and 4. Finally, we do have a constant for this one. It happens to be negative 3. Number 2, don't forget to rewrite this one as addition. So I'm going to rewrite it as 4y plus negative 2z plus 8. My terms, I'm going to highlight those, are 4y, negative 2z, and 8. So you'll see that I listed them here. We do not have any like terms in this expression. I have an extra comma in there. Just ignore that. We do not have any like terms since we have a y, a z, and a constant. So we type or write none. Coefficients. Now we do have two terms, these two guys that contain variables. The numbers in front are 4 and negative 2. Finally, constants, we happen to have one of those. It is 8. It is that number that's by itself without a variable attached. Let me delete that box. Let's just move it down. I'm having some trouble deleting that. All right, number 3. We have 5b plus 2a minus 3 minus 6b minus a. I rewrote this as 5b plus 2a plus negative 3 plus negative 6b. And for the minus a, I wrote it as plus a negative 1a. If there is no number in front of a variable, you can put a 1 in front of it. This one happens to be a negative since we were subtracting a. So my terms, I'll highlight those. We've got 5b, 2a, negative 3, negative 6b, and negative 1a. So let's list those. 5b, 2a, negative 3, negative 6b, and negative 1a. They don't have to go in any particular order. We actually have two pairs of like terms in this problem. We've got the b's and the a's. So you can see here we have a term with a b, so 5b and negative 6b. We've got terms with a's, that's 2a and negative 1a. So you can see I listed each of those pairs. Notice how I separated those like with a comma. Find a way to separate them so you know and I know that they're not all like terms. We have two separate pairs. Coefficients. We've got 1, 2, 3, 4 terms that contain variables. Let's take those numbers. 5, 2, negative 6, negative 1. And it doesn't matter what order they go in. You can see I have 5, negative 6, 2, negative 1. We do have a constant of negative 3 here, as it is a number that's by itself without a variable attached. Last one of these, number 4, 9m minus 1 minus m plus n. I rewrote that using addition, so it was 9m plus negative 1 plus negative 1m plus 1n. My terms are going to be the things that we add. That's 9m, negative 1, negative 1m, get that negative in there, and 1n. So let's make sure we have those listed. 9m, -1, -1m, 1n. Like terms, we have one pair. We've got two terms that contain m's. That will be 9m and -1m. No n's as like terms in this case, since I don't have anything to pair the 1n with. Coefficients, we have 1, 2, 3 terms that have a variable attached. So take those numbers, 9, -1, and 1. And finally, we do happen to have a constant in this case. That constant will be -1. That's this guy right here where my mouse is. All right, so next thing we're going to do, we're going to go over some pretty simple examples where we simplify expressions. Some main steps that I have for you, if the directions say to simplify each expression, is 1, add the opposite. Please, please, please do that every time. Then reorder the expression using the commutative property so that like terms are together or side by side. Eventually you'll be able to skip that step. And then combine your like terms. It's as simple as that. But that first step that I'm going to highlight here in blue is really important for us, because if you don't add the opposite and you go to combine things, you're probably going to be missing some negatives. So in number 5, I've got 4c plus 5c. No need to add the opposite. The like terms are already side by side, so let's combine them. 4c plus 5c, guess what? That's 9c. Number 6, we can add the opposite here. 3a plus 2a minus 5, we can write as 3a plus 2a plus -5. The a's are like terms. I'll go ahead and highlight them in yellow just to indicate that we can combine them. 3a plus 2a is 5a, so our solution is 5a plus -5. Now, if you have 5a minus 5, that's okay too. Number 7, I do suggest rewriting this as 4m plus 1m. Add that coefficient in front of the m. And they are already like terms. They're already being added. 4 plus 1 is 5m. All right. Number 8, just a reminder for those rules, I have them again. In number 8, I do not need to add the opposite, but I am going to rewrite it so the a's are side by side and the b's are side by side. 3a plus 5a is 8a. 2b plus 7b is 9b. So we end up getting 8a plus 9b. Number 9, we should add the opposite here. This will become 4x plus -1y plus -2x plus 5y. Now, put the x's side by side. 4x plus -2x plus -1y plus 5y. Now, this is where you might need your calculator with these negatives. Feel free to plug 4 plus -2 into your calculator for the x's. 4 plus -2 is 2. Then for the y's, do -1 plus 5. That's going to get you 4. So you should get 2x plus 4y. If you follow the rules and the steps here, it should be pretty easy. When you don't follow the steps and you try to skip steps, that's when things become a bit more complicated. All right, number 10, begin by adding the opposite here. We've got -5d plus -2e plus 3d plus -7. Put your d's side by side. So we have -5d plus 3d plus the -2e plus -7. I can combine my -5d and my 3d. -5 plus 3 is -2. So we get -2d plus -2e plus -7.
Okay, so we're going to continue with these lesson 5.5 guided notes and mix in some geometry types of questions, including some perimeter questions. So we're going to be writing expressions to represent the perimeter of a shape. It could be squares, it could be rectangles, it could be kind of what looks like a whale shape in number 12 or a bow tie in number 13, some seemingly random shapes. And we're going to write those expressions in simplest form. So it applies the simplifying of expressions to some more realistic situations. So the directions ask us to write an expression in simplest form for the perimeter of each figure. And I want you to recall that the perimeter of any shape can be found by finding the sum of all sides of a figure. So we have special formulas for rectangles and squares, but when it's not just a rectangle or square, we don't have to break the shape apart in any sort of way. We just add up all the outer side lengths. So in number 11, we've got this sort of odd looking shape here, and we're just going to add up all of the side lengths. So I just started, you just have to pick a place to start. I started at the 2.8y. So I did 2.8y plus 2x. I just went clockwise around the figure, plus 2.2y plus 5x plus 4x. Again, just going clockwise around the figure. You don't have to go in any particular order. I just like to go clockwise so I don't miss any. It's also not a bad idea to maybe cross them off as you go, just to make sure you hit them all. Here, I could actually highlight as I go to make sure that I'm hitting all of those shapes. Just have to move my record button out of the way here. But I've got my 2.8y, got it down there, 2x, 2.2y, 5x, and 4x. The next thing that I like to do, and I really suggest you do this, is put your like terms side by side. So we have several terms that contain x's, 2x, 5x, and 4x, so I'm going to start with those. And I also have several terms that are like terms because they contain y's. That's the 2.8y and the 2.2y. So I rewrote this, I just reordered it, which I'm allowed to do as long as it's all addition, into 2x plus 5x plus 4x plus 2.8y plus 2.2y. Now what I want to do is I want to combine the 2x, 5x, and 4x, those like terms. 2 plus 5 plus 4 is going to get us 11x. I also want to combine the 2.8y and the 2.2y together. And we can use calculators to calculate these, or at least double check our answers. But 2.8 plus 2.2 is going to get us 5y in this case. So our final solution is 11x plus 5y. If you have 5y plus 11x, that's also correct. All right, let's take a look at our next shape, which kind of looks a little bit like a whale. And again, we're just gonna go around this figure and add these all together. I actually started with this 3a at the top and just went clockwise around the figure again. So let's see if I can delete this. Maybe it won't let me delete that box. Okay. Move these out of the way a little bit better. Sorry about that, guys. Just want to make sure this is out of our way. So I've got 3a plus 4 plus the 3a that's at the top plus 2b. And then we've got this little tick mark here, and you might wonder what that represents, but it means that it's equal to the side that's across from it, which also has that single tick mark. So this side, we don't exclude it. We have to use 5a to represent that. So that's this 5a that we have here, plus 6b plus 5a. So again, just because there's nothing written or typed there doesn't mean you just ignore it and not add it in. You just have to recognize that these opposite sides are congruent or equal to each other. So again, I've got 3a plus 4 plus 3a plus 2b plus 5a plus 6b plus 5a. As you gain a little bit of more experience with these problems, you might even be able to reorder them as you write it. But at this point, I'm going to suggest just going with one thing at a time, just going clockwise around the figure, then reorder it, putting our a's side by side. So that's 3a, 3a, 5a, and 5a. And our b's are also like terms, so 2b and 6b, we'll put those side by side. And then we have what we call a constant as well. So we've got 3a plus 3a plus 5a plus 5a. Those are all of my a terms that are like terms. Plus 2b plus 6b. And then, of course, we have our lone constant, which is 4. So we'll just highlight these as we work through. So 3 plus 3 plus 5 plus 5 is going to get us 16a. 2b plus 6b is going to get us 8b, and then of course our constant does not combine with anything else here, so we just add it at the end. Now again, you can put these terms 16a, 8b, and 4 in any order. I usually just put them in alphabetical order or the order in which they're written in the problem. All right, in question number 13, we have a bow tie looking figure. Now we've got a lot of little tick marks here. So we have the single tick marks which represent 4j. So we actually have 4 sides that are of length 4j. So I'm just going to type this in here so we know that these are all 4j. And then we have 2 tick marks, which means they're not equal to 4j, but to h instead. So this side over up here is going to be equal to 2h. So when I add these together, I've got 4j plus 4j plus 4j plus 4j plus 2h plus 2h. Let me just move this out of the way for us. There we go. The 4j's, and you could even write it as 4 times 4j, by the way. Those are going to be our like terms. They combine to give us 16j. And And then we have two 2h's, and you could do 2 times 2h, or I wrote it as 2h plus 2h. But our final solution here is 16j plus 4h. And again, to find the perimeter of any shape, and we're going to see one in number 14, which is a little simpler, but it involves some subtraction, just add up all the outside side lengths. All right, let's give question number 14 a try. It's pretty similar to what I would expect to see on a quiz or a test in this unit. So I started, I believe, with the 3.7x plus 8.6. And then I did the plus, I actually went counterclockwise on this one, which is kind of unusual, but plus 10.3x. And instead of writing minus 5.1, I rewrote that as plus a negative 5.1. Why is that important? Well, if we rewrite it as addition, it allows us to move the terms around wherever we want. If you don't add the opposite, remember subtraction is not commutative, so I really can't move those terms around. So anytime I see subtraction, if I know that I'm going to reorder things and combine things together, I'm always going to add the opposite. And then we have our plus 8.4x plus 1.2. I do want to stress that there is going to come a point in time where you don't need to add the opposite, where you're going to be so good at this kind of stuff that you're going to know that's a negative 5.1 and that you're combining a negative 5.1 with a 1.2 with an 8.6. But for right now, this is our first year really seeing this. I'm really going to strongly recommend you rewrite subtraction as adding the opposite. It's so important, especially as we're working with a lot of negatives in these units. So my like terms are my x terms, and then we have a bunch of constants. So I'm going to put 3.7x, 10.3x, and 8.4x side by side. And then our constants are 8.6, negative 5.1, that's really important, and 1.2. So I did reorder those. So here are all my x terms right here, right there, and then all of my constants are right here. And because we're working with decimals, I definitely suggest using a calculator to at least double check your math. 3.7 plus 10.3 plus 8.4 is going to get us 22.4x, and 8.6 plus negative 5.1 plus 1.2 is going to get us 4.7. So again, just be really careful. If you got something like 14 point, I think it would be 14.9, you might have dropped off that negative on the 5.1, and that is really why it's so important for us to add the opposite. All right, so we have some more difficult simplifying expressions problems on the last page. Let's go ahead and take a look at these. We're going to start with numbers 15 and 16. The reason why these are more difficult is, one, they involve decimals, but also there's a lot of subtraction here. So as I'm always going to recommend, please rewrite it as adding the opposite. Subtraction is adding the opposite. So where I have this, and I'm going to highlight some things here, the minus 4.9y and the minus 5.8y, that becomes plus a negative 4.9y and plus a negative 5.8y. I didn't change the plus 2.6x. I didn't change the negative 7.6x. You always change subtraction to addition and the term or number that follows the subtraction sign to its opposite. I then did put the like terms side by side. So I put negative 7.6x plus 2.6x side by side, and then negative 4.9y and negative 5.8y side by side. So again, use a calculator. Negative 7.6 plus 2.6 is negative 5x. Negative 4.9 plus negative 5.8 is negative 10.7y. So our final answer looks like this. I do want to remind you that if you would see an answer like this, negative 5x minus 10.7y, that is equivalent to negative 5x plus negative 10.7y. Just undoing the adding the opposite and rewriting it as subtraction. We have to be familiar with equivalent forms of numbers. That's definitely an important skill to have. All right, number 16, same idea. I would highly suggest adding the opposite. So I rewrote this thing as negative 8.22a plus negative 4.21a plus 7.68b, and again that minus 4.9 became plus a negative 4.9. Now like terms wise, I do want to mention that our like terms were already side by side. That's going to be these two a terms. So I added negative 8.22 and negative 4.21, and I got negative 12.43a, and then just bring down your 7.68b and your plus negative 4.9, or again that could be written as minus 4.9 as well. All right, let's move right ahead to number 17, 18, and 19, our last three questions, but these do involve distributive property. So let's take a look at number 17. So the first thing that I would suggest you do is distribute that 5 into the parentheses. So when we do that, we'll do 5 times x, and we will do 5 times 2. So that set of parentheses when we distribute becomes 5x plus 10. So just keep in mind, this was replaced with this. 5 times x is 5x, 5 times 2 is 10. Now I did bring down my minus 7x, but I did add the opposite at the same in the same step, which I'm fine with, and I rewrote it as plus a negative 7x. I then put my like terms side by side. And again, there's going to come a point in time where you won't need to do this step. You'll just know 5x plus negative 7x is what I need to combine. 10 is a constant and it's on its own. 5x plus negative 7x is negative 2x. So my final solution is negative 2x plus 10. Now, number 18, it's really tempting to add 2 and 3 together to start, but you've got to distribute first and get rid of those parentheses. So we're going to distribute this 3 into the parentheses. We're going to take 3 times y and 3 times 2. So this is 2 plus 3y for 3 times y minus 3 times 2, which is 6. I did add the opposite in my next step. Some students can add the opposite in the same step in which they distribute. Some students like to add the opposite before they distribute. There's a lot of different options here, but I do suggest if you're going to move things around, which I'm about to, that you rewrite subtraction as adding the opposite. So 3y is on its own, and then the 2 and the negative 6, those are both constants, so they're like terms as well. So I combine 2 and negative 6 together to get negative 4, and my final solution is 3y plus negative 4. You might see that written as 3y minus 4, but they mean the same thing. Now, number 19, we have the distributive property twice. So we've got to distribute this 4 to the 3x and the 4 to the 1, which we'll do in a moment, and then the 3 to the 2x and the 3 to the 3, which again we'll do in just a moment. So that first set of parentheses, which I'm going to highlight in yellow here, becomes 12x plus 4. 4 times 3x is 12x, 4 times 1 is 4. Our second set of parentheses, which is right here, is going to become this. 3 times 2x is 6x, 3 times 3 is 9. Now, reorder it with the like terms side by side. Even though it's all addition, I suggest you do that. We've got 12x plus 6x plus the two constants, which are 4 and 9. 12x plus 6x is 18x, and 4 plus 9 is 13. So expect that we'll see a lot of practice with this. This is one of those skills that really comes back a lot in 8th grade math and also in algebra. So it's something that's going to be exceptionally important moving forward into some of your other math classes. There are careers that use some of this stuff in real life. Depending on what career you go into, if you're going into an art field, you're probably not going to use this, but a science or math related field, you would definitely be much more likely to use these kind of skills and these kinds of concepts. So definitely keep that in mind. Thanks for listening.